Assalamualaikum and a very good day. My name is Izzah Athirah binti Izzah, metric number 221649.
My name is Khairunnaeimi binti Kamarunnizam, metric number 221703.
My name is Maisarah binti Jaafar Akbar, metric number 221755.
My name is Laila Karmila binti Khairunnaeimi, metric number 221723.
And today we will be presenting about application in capacitor. Any combination of two separated conductors can act as an electrical circuit element and is called a capacitor. The conductors are called plates. If the conductors carry charges of equal magnitude and opposite sign, a potential difference exists between them. Quantity of charge Q on a capacitor is linearly proportional to the potential difference between the conductors. The proportionality constants depends on the shape and separation of the conductors. Because of this proportionality, the capacitance C of a capacitor is defined as the ratio of the magnitude of the charge on either conductor to the magnitude of the potential difference between the two conductors. By definition, capacitance is always a positive quantity, and capacitance has SI units of coulombs per volt. Named in honor of Michael Faraday, the SI unit of capacitance is the farad. The farad is very large unit of capacitance. In practice, typical devices have capacitance ranging from microfarads to picofarads. Let's consider a capacitor formed from a pair of parallel plates. Each plate is connected to one terminal of a battery, which acts as a source of potential difference. If the capacitor is initially uncharged, the battery establishes an electrical field in the connecting wires when the connections are made. Let's focus on the plate connected to the negative terminal of the battery. The electric field in the wire applies a force on electrons in the wire immediately outside this place. This force causes the electrons to move onto the plate. The movement continues until the plate, the wire, and the terminal are all at the same electric potential. Once this equilibrium situation is attained, a potential difference no longer exists between the terminal and the plate. As a result, no electric field is present in the wire and the electrons stop moving. The plate now carries a negative charge. A similar process occurs at the other capacitor plate, where electrons move from the plate to the wire, leaving the plate positively charged. In this final configuration, the potential difference across the capacitor plates is the same as that between the terminals of the battery. Now suppose we disconnect the battery from the plates. The plates are not connected with a wire to anything now, so the plates remain charged. The capacitor has stored the charge. It has also stored energy associated with the separation of charge. We will explore these ideas and the use of capacitors after performing a bit more mathematical analysis.
Why does keyboard need capacitor? Okay, keyboard need capacitor to store an electrical charge. When the keyboard button is pressed, the capacity of the parallel plate capacitor increases due to the decrease of the interplate separation distance. Applying formula C equal to epsilon naught times A over D, as the two plates move closer together, the amount of current flowing through the matrix changes. The processor detects the change and interprets it as a key press for that location. The external electronic circuit recognizes every key based on its capacity when the key is pressed. The information carried by the key will go into the computer and displayed on the monitor. But where does the capacitor located in keyboard? So, the capacitor located at the bottom of the keyboard keys. Key is connected to a movable plate with the first plate of the capacitor. The fixed plate at the bottom of the keyboard acts as the second plate of the capacitor. Okay, so capacitive switch keyboards are expensive, but they have a longer life than any other keyboard. Also, not have problems with bounce since the two surfaces never come into actual contact.
Okay, so how does the capacitance in the keyboard works? Firstly, we already know that a capacitive keyboard works with electricity always flowing in them, and under each key, static charges is stored in the capacitor. And while the key is pressed, it will alter the capacitance in the capacitor. Thus, the keyboard will identify and register every exact keystroke. Okay, when you look at the picture here, a keyboard button is connected to a few parts. One, the key is connected to a moving plate which acts as the first plate of a capacitor, And then the dielectric, which exists between the first and the second plate, which is known as the fixed plate, located at the bottom of the keyboard. So when a key is pressed, the distance between the moving plate and the fixed plate will decrease to about 5 mm to 0.3 mm, and this resulted in the increase of the capacitance. In other words, the deduction in the separation distance of the two plates is the one who causes the capacitance to increase. This happened because of the basic workings of the capacitor. The capacitor in the circuit is the flow of electrons through the capacitor. When the electrons has been filled in the capacitor, naturally the voltage will also change accordingly. And while the electrons will then flow away from the capacitor, it will go into the circuit, which results in the capacitor to generate a reactive circuit. Therefore, we can conclude from this that when a key is pushed down, the soft insulator between the movable plate and the fixed plate is compressed. So when the key is pressed, what will happen to the capacitance? It will increase. Okay, so now we move on to how to count the capacitance in the keyboard. Okay, so we look at this question. The separation of the plates is normally 5 times 10 to the power of negative 3 meter, but it decreases to 0.15 times 10 to the power of negative 3 meter when a key is pressed. The plate area is 9.5 times 10 to the power of negative 5 meter square, and the capacitor is filled with a material whose dielectric constant is 3.50. This 3.50 is, the symbol is K here, and they want us to determine the change in capacitance that is detected by the computer, meaning that they want us to determine the capacitance when the key is pressed and the capacitance when the key is not pressed. So to find that, we use this formula because they already gave us the dielectric constant 3.5. Okay, so we use this and then we put in the value. So when the capacitance when the key is pressed, we use D equals to 0.15 because they said that it decreases to 0.15 times 10 to the power of negative 3 here. So we use this one, and then we get 19.6 times 10 to the power of negative 12 F. And for when the key is not pressed, we use D as 5 times 10 to the power of negative 3 meter. And then we get 0.6 times 10 to the power of negative 12 F. And to calculate the change is we minus the capacitance when it is pressed minus the capacitance when it is not pressed. And the final answer is 19 times 10 to the power of negative 12. Finally, the change in capacitance is greater with dielectric present, which makes it easier for the circuit in the computer to detect it.
So now I'm going to talk about a capacitive keyboard. So what is a capacitive keyboard? A capacitive keyboard is a keyboard design that uses changes in stored static electricity or capacitance on the capacitor pad to identify when a key is pressed. This is different from contact keyboards that uses changes in electricity flows to initiate the register of keys when a user presses a key. Here are some examples of a capacitive keyboard. How is a capacitive keyboard different from a mechanical keyboard? The mechanical keyboard is made up of a complete switch beneath each key. These keys can be bumpy, linear or tactile, and pressing on the keys produces feedback that lets you know your keystroke has been registered. A capacitive keyboard is made up of a capacitor membrane which, when pressed, triggers an electrical response. A mechanical keyboard relies on its physical structure to register a keystroke on the computer. However, a capacitive keyboard uses the electric impulse on the capacitor membrane to receive and register the keystroke. Pressing a key doesn't trigger a physical switch. Instead, it nudges the electric capacitor. There are a lot of advantages on using the capacitive keyboard. One of it is, this method of triggering the keys on the keyboard makes operating the keyboard smoother and less noisy. This makes it better for use in quiet offices or spaces. Secondly, it is faster than mechanical keyboards in registering key presses, making it a great choice for typists or professional gamers. And thirdly, it requires only a small push to register the stroke, relieving you of typing stress. but there are some disadvantages too. So one of the disadvantages is if you do not need precision typing, this impulse receptor might be bad for you. You may make too many mistakes because of the speed of the capacitor in registering key presses. And secondly, you may feel less in control than with a mechanical keyboard.
To conclude, keyboard is one of the application of capacitor. Capacitor is a combination of two separated conductors that can act as an electrical circuit element. Capacitor used to store electrical charge. Each key will be recognized based on its capacity. When a key is pushed down, the soft insulator between the movable plate and the fixed plate is compressed. When key is pressed, capacitance will increase and the information carried by the key will go into the computer and displayed on the monitor. Capacitive keyboard makes operating the keyboard less noisy and faster, but it may cause many mistakes because of the speed of the capacitor in registering key presses. That's all from us.
Thank you.